Transformed sinusoidal functions. Explain how the following functions are related. A, B, C, we are given three sinusoidal functions. Y equals to sine x, y equals to sine of 3x, y equals to sine 0.5x. Now how are they related? Well, these are, all three of them are sine functions. So they have same amplitude, axis, and all the characteristics except for one, and that is their time period, correct? So time period is what makes them different. Now let's look into time period of each. Starting with the very first one, which is sine x, time period or one cycle of sine x is completed in 360 degrees. So the time period is 360 degrees. For sine of 3x, we have three waves in 360 degrees. So one wave's time period is 360 divided by 3, and that is 120 degrees. In case of sine of 0.5x, we have half the wave in 360 degrees. So the time period is 360 degrees divided by half, or 0.5, which is 720 degrees. So that is how these three functions are related. Now let me show you with the help of a sketch how they look like. So let's draw these lines. They are x-axis lines for us, and that is the y-axis for each. Okay. So basic sine function will be kind of like this. That is a sine function where it starts from 0 and one cycle is completed in 360 degrees. Let me write 360 degrees here. It goes from maximum value of +1 and minimum of -1. So that is how a sine function, sine x, will look like. So let me write this as y equals to sine x. And on this axis we have x. Now when we have a function sine 3x, what it really means is that within this time period of 360, let me just draw a dotted line here, we'll compare all three of them. There will be three sine waves in this period. So that means we'll have kind of, well, this is even bigger. So we'll have three waves here. So sine function will be kind of like this. 1, 2, 3. Well, it's not very accurate, but it gives you an idea. Now here, as you can see, the time period of each is 1/3. So from here to here, one wave, it will be 120 degrees, then 240, and then this will be 360 degrees. So there will be three cycles of sine wave going from 0 to +1 to -1 and then back to 0. Now in case of y equals to sine 0.5x, we will have half the wave within 360 degrees. So actually the wave will kind of stretch. So in this case, the original wave, which was kind of like this, right, it stretches to twice the distance. So that is what it means by 0.5, and we'll have only half the wave here, right? So we'll have one wave which will be having a time period of 720 degrees, like this, where the time period will be 720 degrees. So within 0 to 360 degrees, we'll have just half the wave. So that is what it means by 0.5, half the wave. And if it is 3, we'll have three waves in between 0 to 360 degrees, and here we have just one wave, and the time period is 360 degrees. So that is another way of looking into it. So when we have sine x, the time period is 360, one cycle is completed in 360 degrees. Sine 3x means There are 3 cycles completed in 360 degrees, and the time period of 1 is 360 divided by 3, which is 120 degrees. And if it is half of x or 0.5x, half the cycle is completed in 360 degrees, and the time period of the wave sine 0.5x or sine of half x will be equal to 720 degrees, right? So I can write always this as sine of half x, right? 0.5 is half x. That's what it means. I hope that makes things clear. So this k value tells you number of waves within 360. Thank you.